How's everybody doing? All right, let's try that again. How's everybody doing? Everybody good? All right, that's a little better. We got enough beer, we got enough pizza, everybody happy? All right, cool. So welcome to DevOps and Drinks. My name is Alex Dubovoy. I started this thing about a year and a half ago. We started with one meetup and about 10 people showed up. And I am very excited to say that we have more than 10 people today. Our group actually has about 1,350 members in the past year and a half. And that could not be done without everybody here, without our sponsors, without our hosts, without our presenters. So thank you to GIPHY, thanks to Armory. Bryant, thank you. We'll introduce these guys in a quick second. Quick lowdown. Who am I and what do I do? My name's Alex Dubovoy. I work for a company called Averity. What do we do? I am a recruiter. Yeah, that's not my usual reaction. All right, but in all seriousness, our team places DevOps engineers, site reliability engineers. We just opened up our security division for the cybersecurity side of things. And we believe in one thing: people hire people. Treat people as such. Respect the fact that changing jobs is a life-changing process. It's a big deal. We treat people that way. Ask around. You'll hear. But big thing, we're not going to be out here just gunning business cards at you all day, trying to recruit you into jobs. I say it all the time. I genuinely mean it. I'm not here to recruit anybody today. We're here to have an awesome event and have a good time. I'll be in the back chilling, having a beer. But if you are looking for a job, if you do want to talk about the state of the market, you should come by. Say what's up. Say hello. If you're not looking for a job and you just want to say hello, it's okay. I like talking to people. But hang out, enjoy the presentation, enjoy the event. We do these every month, and it couldn't happen without you guys and everybody here. So I'm super psyched about this. We love GIPHY. This is the third time that GIPHY's hosted a meetup for us. They are an amazing environment. The people are great, and they are hiring. So without further ado, Bryant Rockoff at GIPHY.
Hi, everybody. So yeah, my name's Bryant Rockoff. I'm an SRE engineer here at GIPHY, along with my awesome two partners, Brian and Anthony, who are around here somewhere. Brian's right there in front, and Anthony's all the way in the back. He's our director, so talk to him if you're interested in working here. So today we're going to talk about Spinnaker at GIPHY. We're going to go over how we're using it, what we're using it for, all that kind of stuff. Now I got to hope that this button works. Aha, nope, went too far. There we go. So we are part of GIPHY Engineering. We're a team of about 35, I think now, or something like that. And we are growing. But I also want to introduce our co-sponsors for the evening, which is Armory. They are an enterprise Spinnaker partner. We've actually partnered with them here at GIPHY to help us get Spinnaker out the door. As a small team of 3, Spinnaker is a large product to take on ourselves. So they've been great at helping us get Spinnaker out the door. So I want to introduce Ed from Armory, who will tell you a little bit about it.
Thank you. Hello, I'm Ed. That's Justin. That's Lee. Yeah, I know. We're from Armory, and Armory is helping deliver Spinnaker to the enterprise. I want to focus this evening on watching what Bryant's built and what he's going to present you. But after the fact, we're here. We're also out on the internet, armory.io. Find me in person, find us on the internet, and we'd love to tell you more about some of the cool stuff we do with regards to Spinnaker. That's about all I'm going to say here. We're not launching into the whole thing. This is about what GIPHY's been doing with Spinnaker. But there are a couple of little spots you might notice. What GIPHY's been doing with Spinnaker is enabled by what Armory's provided. So that's all. Thank you. Great to be here.
Awesome. Thank you guys so much. And thank you guys for coming, even if you just came for the pizza and the beer. We really appreciate you being here. So thank you. Shameless plug time. Like I said, we're part of GIPHY Engineering. You can hit us up at GIPHY on Twitter. Engineering.giphy.com is our blog, where you can find out all the cool stuff we're doing here, and jobs.giphy.com if you're interested in working for us. And as a developer, if you're interested in using GIPHY in your product, we just actually launched our GIPHY SDK. You can go to developers.giphy.com to get started with it today and put GIPHY into your application. Okay, but you're all here for an obvious thing, and you want to know about what is Spinnaker. And I am so happy you guys asked. So let me give you the rundown. Spinnaker is an open source, multi-cloud, continuous delivery platform for releasing software changes with high velocity and confidence. And it's created by our dear friends over at Netflix. Aha! That's it. We can all go home. That's it. We're done. I'm kidding. Let's talk shop. So we're going to talk about a couple things today. We're going to talk about continuous integration versus deployment, what's one versus the other. We're going to talk about the tools we're using here at GIPHY and how we've kind of implemented Spinnaker. We're going to talk about how we use it. And then we're going to talk about its many pitfalls that we've had to endure so you don't have to. But today we're going to specifically just talk about Spinnaker on Kubernetes. We're a Kubernetes shop. We run Kubernetes on AWS via kops. So for those of you who might be interested in, for example, using Spinnaker to create AMI instances or images and Google images via Packer, we're not going to talk about that today, but I have actually used Spinnaker for this in the past. A lot of the pipelines you'll see do translate over to how you would build those kind of images. So whatever you see, you should be able to do with those machine builds. Feel free to talk to me afterwards. I'm happy to answer any questions you might have. Okay, so for those of you who might not necessarily know the exact definitions of what continuous integration, continuous delivery, and continuous deployment is, when we talk about continuous integration, we're talking about the continuous integration of your code into its code base. So running unit tests when we push to branches and make our pull requests, run our integration tests when we merge to develop or master. We do code quality checks during this period, right? This is where we get to tell the developers just because it works on your Mac doesn't mean it works out in the ether. So this is your first line of hope of detecting problems, right? To figure out if maybe something's wrong with the code that currently exists. Then there's continuous delivery. That is, we've run through the continuous integration suite. Now we're going to give you the ability to deploy out your code at any given time at will. So deployments to environments, deployments to staging, deployments to production, right? For a lot of us, this probably looks like building Docker containers, packaging up our binaries, our jars, whatever else, so that our developers can get them out the door. But there's still a little bit of a process to this. Maybe you have to manually hit a button. Maybe you have to use kubectl manually to get things out the door. Who knows? And then last is continuous deployment. This is kind of what we're all aiming for. This is like the last piece of the puzzle. We've gone through our integration checks. We've given you the ability to deliver your code, but now we actually want to deploy it automatically, constantly, get it out the door, right? This is the there's no stopping us now of delivery, in that you push a piece of code to GitHub, we merge it to master, it goes, and there's no stopping it now. Cool. So here at GIPHY, we're kind of more on the continuous delivery side still. There are still manual parts of our process, even with Spinnaker, but we're aiming to be continuous deployment by like early to mid 2020. So what is Spinnaker for? Spinnaker is for CD. It's for continuous delivery and deployment. It is not a continuous integration service. So you're going to want to come with your pre-built binaries and Docker containers. You want to come with your Helm charts that have already been pushed and made available via the cloud. You're going to want to come with your secrets. None of that is handled by Spinnaker. And if you try to make it handled by Spinnaker, you're going to have a bad time. I promise you. So you're still going to need your Jenkins. You're still going to need your Circle CI. You're still going to need your GitLab and your Google Cloud build, right? You need something to help get you to the door of Spinnaker, and Spinnaker then helps ship it out to the world. Keep Jenkins in mind, though, because it's a first-class citizen inside of Spinnaker, and we'll talk about that in a few. So here at GIPHY, we use Jenkins for our continuous integration. It will build out our Docker containers. It will package up our Helm charts, put them into an S3 bucket for us. This is where we run our integration tests and things like that. And then there's Spinnaker, which helps to create environments, run Canary Analysis, which we'll talk about, and also deploy out to staging and production and things like that. But Jenkins and Spinnaker together are really a lovely match. They really just work well together, and we're going to talk about what that looks like here in a few. Really quickly, you're going to see some tools throughout this process. I just want to make sure we're kind of familiar with them. Like I said, we are primarily a K8s on AWS shop. So that's what you'll be seeing as far as Kubernetes. We use Jenkins for our continuous integration, Spinnaker for our CD platform. We use a combination of Kong, Nginx, Ingress, and Istio for our ingress. But what you'll see today is mostly demonstrating Nginx. We use Helm, obviously, to package up our Kubernetes manifests, as I've kind of mentioned. Chart Museum to store those Helm manifests and make them available for download. Monocular, which is an open source tool that allows you to get a little visual of the Helm charts that are available to our developers. And Vault for our secret management. Any questions before we move forward? Awesome. Cool. So now we're going to get to the heart. Oh, yeah, sorry. That's a great question. We use Vault for our secret management, not Helm secrets. Completely viable option. For those who might not know, Helm secrets actually saves your secrets as an encrypted file inside of Git and then makes them available for deploy. Not something we currently use. I've used it in the past. It's great, but we use Vault here. All right, cool. So Spinnaker GIPHY, let's talk about this. Before we get into the specifics, I just kind of want to show you what Spinnaker looks like. This is a high-level overview of Spinnaker. It actually consists of 10 microservices. I'm not going to go in depth on all of these because it's a lot, but just to give you a quick high-level overview, when we talk about Deck, that's the user interface. There's a service called Gate, which is the API gateway into Spinnaker. There's Cloud Driver, which handles indexing our caches and cloud resources. There is Kayenta, which handles automated Canary Analysis. Essentially, we have a bunch of microservices we're deploying out that allows Spinnaker to run. A couple of ones to keep in mind, though. Halyard is a really important one. Halyard is something you're going to use all the time with Spinnaker. It is the command line that actually helps us configure Spinnaker. This is like the kubectl for Spinnaker, but it has a really important process. The configuration file for Spinnaker is massive and makes no sense. So this helps to actually configure that file for you, make sure the configuration is accurate, and get it out the door. Then there's Orca, which is our pipelines written in JSON. This is the actual service that runs our pipelines for us. We can template out those pipelines via YAML and also Go template via a service called Dingy, which we'll talk about in a little bit. And this is essentially what it looks like. So you'll see this in Spinnaker. This is a pipeline. This is the JSON that a pipeline would render as. And we'll kind of go into this a bit, but just to give you an idea. Let's talk a little bit about this Jenkins and Spinnaker integration, which is handled by a service called Igor. There are 3 ways that Spinnaker kind of runs and interacts with the locale that we're deploying out to. The first thing to keep in mind is Spinnaker needs information to be able to deploy out your application, right? There are ways to do this manually. You can set up parameters inside of Spinnaker, but in general, you're gonna wanna let Spinnaker know when something's ready to be deployed out, right? So Jenkins can trigger Spinnaker and provide information about what is actually getting deployed out, right? The other thing to keep in mind is Spinnaker can run Jenkins jobs. So that's really important in a lot of pipelines. Spinnaker is only good at a few things. What Spinnaker can't do, Jenkins can. So you can run Jenkins jobs directly through Spinnaker and make things available through your pipeline. And the last thing to keep in mind is Spinnaker can run Kubernetes jobs. You might ask, when would you might want to run Kubernetes jobs over Jenkins jobs? We'll kind of talk about that, but just keep that in mind. Okay, so let's just look at some data that we send from Jenkins to Spinnaker. This is JSON that gets generated by our Jenkins instance. We'll kind of delve into it in a second. This is a bake Helm chart step inside of our pipelines. And here's an example of something that we send from Jenkins to Spinnaker that we need inserted into our Helm chart. So this step bakes our Helm charts. It actually injects information into our manifests. We send an image tag that has been created via a Jenkins pipeline, Jenkins build, and that gets injected into the Helm chart. These are called Spinnaker parameters. These are going to be used all over your Spinnaker pipelines. For those who might not be super familiar with Helm, really quick, there's actually an important thing with Helm. It's a templating system for manifests, just Go template essentially under the hood. But to kind of see how this gets injected, this image.tag, we have an image tag value in our values.yaml that gets inserted into our deployment YAML via Go template. How do we generate this information? Well, you generate it with Jenkins, but we highly recommend something like a Jenkins shared library. Jenkins shared libraries are awesome. They allow you to insert code, not deduplicate it, like it's an actual library of code for Jenkins. We've used this a lot we've heavily invested in Jenkins, but we didn't want to rewrite code so many times for all of our Jenkins files, right? So this shared library is awesome. To give you a very quick overview, I'm not going to delve into it too much, but there are these functions that you can build out with a Jenkins shared library, all written in Groovy. I'm so sorry. And you can then add them into your Jenkins files. So things like we render a bunch of information via a variable Spinnaker function that essentially that generates information based on environment variables inside of Jenkins. We push through our Jenkins shared library. We trigger Spinnaker through our Jenkins shared library. And shared libraries can be injected into your Jenkins files with just a single line at the top of your file. They are awesome. So if you're interested in Spinnaker, it's certainly not required to use a Jenkins shared library, but it's going to make your lives a lot easier in terms of rolling things out. So there's two ways to trigger Spinnaker with Jenkins. There's a webhook type, and there's a Jenkins type. Webhook type literally sounds exactly like it is. We generate a JSON payload, and we send it to Spinnaker. And then there's Jenkins type, which is actually a polling mechanism where Jenkins finishes a job and Spinnaker recognizes it as finished. It's finished a specific job, and it starts whatever pipeline we tell it to. Why might you want to use one over the other? Well, with webhooks, we'll kind of get into this. Anybody can push a webhook. If you have a webhook secret, if you actually have a payload constraint that you send to Spinnaker. So it's a little dangerous to just have, let's say, deploying to production. So Jenkins polling allows us to make sure we only ever deploy off of, let's say, our master branch, rather than anybody being able to push to an environment that we have. But let's kind of delve into the webhook, because I think it helps to show exactly what the information we're sending to Spinnaker looks like. And there's three important things to keep in mind here with webhooks. There's an artifact, which is very important, which we'll touch upon in a second. There's parameters. Parameters, variables that we need Spinnaker to know to inject into Helm, right? So we're going to pass them into Spinnaker via this JSON. And then for webhooks, you can also have a webhook secret. It's a payload constraint, where if you send a payload to Spinnaker, but it doesn't include that webhook secret, the job's not going to trigger, right? But I want to focus on artifacts, because these are probably the most important part of Spinnaker, and it's the thing that confused me the most. Spinnaker uses artifacts as objects that reference external resources. So things like a Docker image, a file in GitHub, a machine image, a binary blob in S3, right? These are things that are injected into your pipeline that keep them, I guess sane is a good word for it. The idea here is that every pipeline that you trigger has a reason for being triggered. And we want to make sure we can replay those pipelines in the future if we need to. But if Spinnaker doesn't know why it was being run, there's no way for it to actually be rerun. This will make sense in a minute, but here at GIPHY we use Helm via S3 to actually be our artifacts. So keep that in mind. Spinnaker wants your artifacts. It needs your artifacts. It craves your artifacts. So like I said, we can trigger Spinnaker via a webhook. That's the first way of doing things, right? In this particular case, we generate this JSON and we send it to Gate, which is that API gateway I talked about earlier for Spinnaker. And that JSON payload gets sent and is triggered the pipeline. Now, this is a JSON payload for a Jenkins polling job. And you're going to notice it's a little bit different. There's no artifact and there's no webhook secret, right? Well, then how are we sending Spinnaker an artifact? Well, we do it with these two values. We send it a message format and custom format is true. What? So first of all, unlike a JSON webhook, we actually are going to store the JSON that's generated as an archived artifact in Jenkins. So in Jenkins, we generate the spinnaker.json file. This is our automated trigger for Jenkins. In this particular case, we're monitoring the master job of our spin pipe job, right? So when we push to master, it's going to trigger via Spinnaker because we completed that job. And Spinnaker is going to pick up that JSON file for us. And those are the properties it's going to use to actually run. So we've got this message format and a custom format equal true. What do we do with that? Well, you can actually provide Spinnaker custom artifact templates for Jenkins. Don't ask me why you do things this way. This is just how they want you to do it. So a custom artifact type, essentially it looks like a Go template. Instead of us directly sending an artifact via a webhook, now we're just providing Spinnaker the Jenkins variables, and it's rendering that artifact for us before the pipeline starts. And that's essentially how you would do that. Okay, so we've got an artifact now. We've generated one via a webhook, which is a direct push, and we had Spinnaker actually create an artifact for us based on the variables we've sent it. Where does that actually get ingested? At the start of your pipeline, there is an expected artifact that has to come with your pipeline for it to know how to run properly, right? So in our case, we're sending an S3 Helm object. That is right there. So essentially, we're saying to Spinnaker, unless you get a Helm object from this S3 bucket, you can't run. And that's really important for two reasons. Number one, we want to make sure we're deploying out things that we actually want to deploy out. And number two, it's a good way of stopping Spinnaker from running if we don't want it to run. In our case, we have a giant monorepo. We don't necessarily want every master build to trigger the same job. So there are ways for us to ensure that we either don't send a webhook artifact or a message format so we don't trigger a pipeline accidentally. So if we don't send that information, Spinnaker's like, nah, man, can't do that. You didn't give me the information I need. So it just doesn't run the pipeline. Like I said earlier, you can also, with webhooks, stop pipelines in another way, which is just not sending a payload constraint. So if you don't send that, Spinnaker's like, nah, man, I can't help you. Sorry. But, okay, so that's Jenkins triggering Spinnaker. Let's talk about a Jenkins job that Spinnaker runs inside of its pipeline. In our particular case here at GIPHY, like I had mentioned, we use Vault for our secrets. So we actually have a step in our pipelines where we go out to Vault, grab our secrets, inject them into Kubernetes, and then load them into Helm, right? So this is what a Jenkins job looks like. That's kind of blurry. I don't know why it's coming out blurry like that. But a Jenkins configuration, essentially you give it a job that you want it to trigger, and you tell it, these are my parameters that I need you to run the Jenkins job with if it has parameters. And then you tell it, is it going to create a property file? Kind of like our trigger earlier, we are looking for a property file from Jenkins to be able to feed more information further on. In our particular case, that's the JSON we generate for our secret creation. We actually create secrets inside of Kubernetes, and we need to take those secrets that have been generated and add them into our Helm manifests. So what that looks like is that we created a primary secret inside of Kubernetes using that stage, and then we inject it into our Helm chart. Now, this is slightly different than triggers because with a trigger, we are sending what are called properties to Spinnaker. With a stage completion, you actually call that stage's information as a context, and you grab those variables. I'm not going to delve super into the specifics of this, but just know there's really good documentation on the differences between the two on Spinnaker's website if you're interested. And again, for those who might not be as familiar with Helm, like I said, we want to inject the Helm secret ref primary value that we've generated into Helm. So we want it to go here in our values file, and Spinnaker is going to do that, and then it inserts it into our deployment like that. Important thing to remember, generally, whatever Spinnaker can't do, Jenkins can. And that's why it's really good to have Jenkins on your side with Spinnaker. And with that, I'm going to show you our first demo. And hope it works. Okay. Okay. All right. So I've got this app called SpinPipe. It's a very, very simple little app. I'm literally just going to make one value change, but it's going to help you understand exactly how we're kind of using Spinnaker here, I hope. And this process takes about 3 minutes to deploy out, so I'm going to take questions while it's doing it. But what I want to do right now is go to Visual Studio Code. Let me just show you really quick. We've got this app running. Looks like that. It's just a little GIF, and we want to change that GIF because I love that GIF, but I think I'm ready for a new one. So let's go to GIPHY. Let's go find another Pokemon GIF. Let's say I want, yeah, Pikachu and Eevee. Let's go. Okay. So I grabbed that GIF link. This is the container that I have. It's literally just an HTML file. I'm just going to update the value of the GIF that I have. So let's go ahead and update that. I'm going to go to my terminal. Status. Looks like I've got something ready to go. All right, let me just get pulled and make sure I've got the update. Cool. Let's check out a branch. We'll call it feature Pikachu. Awesome spin GIF. I don't know. And now let's go ahead and add that change. Update that value. And push it out. We'll call this, I don't know, awesome new GIF. Cool. So what am I doing? I'm creating a new branch in Git, and a couple things are going to happen here. First of all, like I said, we need Jenkins to run first, right? Jenkins actually needs to build out our container so we can then ship it to Spinnaker. So we go to Jenkins. Here's our lovely Jenkins. We can see that we've got Jenkins running. It's picked up that branch. It's going to now run a process and build that image. This will take a second, but what will happen eventually is when it's done, and it takes about a minute, we'll see that Spinnaker now is going to be triggered. Couple things to keep in mind, just keeping things in motion. Like I said, we have a way of searching our Helm charts here at GIPHY. So in this particular case, I have a Helm chart in my Git repository for this app called SpinPipe. Developers can search for it if they want to launch it themselves. Looks like that. Oop. There it goes. So they can get information about the Helm chart, how to add values, things like that. And all this information comes from Chart Museum, which is pretty cool. Great. So that's now built. If we go to Spinnaker, into our SpinPipe app, we will see that our pipeline is running. Hooray. How did that happen? Well, Spinnaker, Jenkins completed its job. It ran a webhook, sent a bunch of information to Spinnaker, and now Spinnaker is going to start this process. Let's kind of dig into this pipeline because it's a very basic one. So at GIPHY, we use a pipeline called SpinPipe environments as a webhook type to be able to generate environments on the fly if you request one of us. And in our particular case, we use the word spin as an indicator that you want a Spinnaker environment. So there's a couple steps to this. We create an environment namespace. And GIPHY, we, like I said, we use a Vault to actually get secret information into Kubernetes. So we have to generate a service account and a role binding for Vault to be able to go out and grab its secrets. And we create a namespace for every environment that we create. So that way we can go out and destroy those environments in the future if we want to. And we do. Then the next step is going to be that create secret steps. Like I said, we run a Jenkins job. It's going to go out to Vault, grab those secrets, inject them into Kubernetes. We bake our Helm chart with the values that we've generated. And then we deploy it out. So this step takes a minute or two. So while it's running, and then I can show you that it works. Does anybody have any questions? Yes. You know, actually, I'm going to give you the microphone because I couldn't super hear that. I'm sorry.
So why can't we use kubectl commands to deploy instead of using a Spinnaker?
It's a great question. So first of all, kubectl has a limitation, which is that it's not really good at templating things, right? So if you have static kube manifests, you can definitely do that. There's nothing stopping you from doing it. But the problem with static manifests, which by the way, we used here at GIPHY before this process, is that they're static. So if you want to duplicate a deployment or an environment, you have to create a whole new set of manifests, right? And that gets tiresome and tedious after a while. So there's nothing stopping you from doing it. And by the way, you can also use the Helm command line directly to deploy environments. The reason why we do it this way is because there's an automated process to it, right? Our developers don't have to have access to the environments. We can create those for them. Cool. Still finishing up the deploy. Any more questions while it's finishing? Yes. Yes, we did. And that's exactly why we used it. Google Cloud, by the way, can also do a lot of the same things that Jenkins can. Google Cloud build can be called both in and out of Spinnaker. So you can do a Google Cloud build, trigger Spinnaker off of it, and have Spinnaker run a Google Cloud build inside of its pipelines. It's just not as dynamic, to be super honest. Like, there's a lot more you can do with Spinnaker, I think, in that regard. Yeah. Or Jenkins, sorry. Right now it is. There supposedly are more coming in the future, but as of right now, yeah, Jenkins is definitely the one they've invested the most time into. All right, cool. So our build is done. Let's see if my demo didn't break. So in our particular case, like I said, we send a lot of information to Spinnaker. Let me kind of make this a little bit bigger. In our particular case, we actually generate the namespace we want Spinnaker to create on the Jenkins side and then tell it to create that namespace for us, right? So that's that right there. We also send it an ingress URL to create. So part of this process, if we look at our execution, is we deploy out a config map, a deployment object, an ingress, and a service. All of those things are part of our Helm chart. Those get generated and deployed out via Spinnaker. So let's try and hit that ingress URL that didn't exist before this. There you go. There's our brand new app with a super new cool GIF. And now we'll be ready to possibly deploy it to production. So let's see what happens. But before that, let's go back to our slides, and we're going to get back to Spinnaker in just a minute. Oh, I got to stop sharing. Sorry. Okay. Before we move on, any more questions before we keep going? Okay, awesome. Oh, yeah.
You've mentioned the artifact. The artifact is just a Helm chart, and then the container itself gets pulled down from a registry?
Yeah. So the container itself, in our particular case, we inject the container information into the Helm charts, and then the containers get pulled down by Kubernetes when those charts get deployed out, right? So in our case, our artifacts are the Helm charts that we want to bake and deploy. But that isn't always the case. Sometimes you're going to have a binary you want to deploy. Like I said, you can build entire Amazon machine images with Spinnaker. So in those cases, you most likely would want to grab a binary and insert them into your Amazon machine images to run, right? Your artifact could be a Docker container. There are a lot of things an artifact could be. There's an entire list on Spinnaker of like what artifacts can be, but the general idea is we have two big things that we want to trigger on. We want to trigger on a Helm chart change and a Docker container change. But the underlying Helm chart is the important thing for us, because the Helm chart is the thing that we have to actually modify through the Spinnaker pipeline. Not an Amazon machine image, not even a Docker container, because it's already been built. It's the Helm chart that we want Spinnaker to templatize and make available to us. So that's why the Helm chart is the manifest object, or artifact, sorry.
To what you just said, if you had to ship just the config changes, how would you do that? So there is no changes to the container itself, but a variable within the container changes.
So two things. Number one, I didn't show this, and I can totally demo it after the presentation, but you can change a value inside of Vault, for example, and rerun a pipeline, and it will deploy out the same Helm chart and the same container that previously ran the pipeline and just change the underlying secrets that power it. So for example, if you wanted to update a URL for a service, you could do that inside of Vault, then just rerun the pipeline, and those changes would get deployed out because the create secret step would go grab those new values and insert them into the Helm manifest. Yeah, cool. All right, so before we get to our last demo, I just want to talk about two more quick things. The first one is, like we had talked about, you can use Spinnaker to actually trigger a Jenkins job, and you can run Canary Analysis with Spinnaker. So, for those who aren't super familiar with Canary Analysis, this is something that we've recently just deployed here at GIPHY. But the essential idea of this is we have a service out in the world that we know works. And we have now made changes to that code, and we want to make sure that the code actually works the way we think it should compared to what has previously been made available to the public. So how do we do that? Canary Analysis essentially is the idea where we take a copy of what's in production, we duplicate it, and then we compare what is currently in production to the new code that we have generated and created, right? So this process, if you look at the pipeline, and we'll go into this more in depth, is we duplicate what is currently in production as a baseline deployment. We deploy out our canary, and then we do some analysis against that. And I'll show you what that looks like, but essentially, we want to create a whole new deployment object because of two big reasons. Number one, our metrics in a lot of cases are average-based, right? We don't want historical data to influence the way the Canary Analysis is read. So if we look at just the metrics that are coming from our mainline in production, then we might get some misread data. The other big thing is there's a lot more servers of our production code that are running than the Canary, right? So in order to really be able to get metrics that allow us to define if a canary is working compared to the current code, we want to separate out production and then be able to compare them. So let's talk about this pipeline a little bit. We're going to dig into Canary in a second, but I want to talk about creating a baseline version. Spinnaker can't do that out of the box. So what we do is at GIPHY, we actually use a label called a track. We have our mainline production deployment called a stable track. And then what we need to do is we need to take that deployment object, duplicate it, and say to Spinnaker, say to Kubernetes, this is now a baseline object. This is what we're going to use to test our canary against. So we're just updating that value, essentially. The problem is, like I said, Spinnaker can't do that out of the box. So what do we do? Well, we could use Jenkins, right? Like I said, Jenkins can do anything Spinnaker can't. But there's two things. Number one, this could easily be done directly inside of Kubernetes. There's no need to use Jenkins. But also, the big thing here is I don't actually need any information about what's created. I just need Spinnaker to do something. I don't need it to send back any information to me in this particular case. So I can run a Kubernetes job, which I can immediately and quickly attach a service account to for RBAC to duplicate deployments and things like that directly through Spinnaker. So there's no reason for me to call out to Jenkins here. So the cool thing about Spinnaker is that you can run a Kubernetes job directly inline inside of a pipeline. And it looks something like this. So you can use the same Spinnaker properties that we've sent to it, inject those into the manifests, and yeah, pretty simple. It's a simple little YAML chart. You've seen these before for Kubernetes. But that gets tedious for two big reasons. Number one, our JSON in our Spinnaker pipelines is massive now because we've all of a sudden injected all this information into it. And also, we can't parameterize that stage in any way very easily. So if our developers want to actually change a value that needs to be set, for example, the replicas we want to generate, there's no easy way to do that directly through a job manifest inline inside of Spinnaker. So there's got to be a better way. And there is, and they're called custom jobs. So one of the cool things that Spinnaker just added in the latest version is the ability to essentially create your own stages inside of Spinnaker to do whatever you want with Kubernetes jobs. So here's that same thing that you saw now available to all of our developers. And we can even give them, like I said, some very simple little parameters, like what namespace is the deployment you want to duplicate in, right? And then how many replicas do you need of the baseline? And that's important because we might want to, let's say, deploy a couple baseline and Canary pods to test against. So very simple little job. This is essentially what it looks like. Orca, like I said, is the orchestration service that you use to run pipelines. So you can feed it a bunch of pre-configured jobs and information when you deploy Spinnaker. This is essentially what it looks like. There's how you render parameters, and here's the manifest inside of the Orca configuration. So, okay, but let's talk about what I think is the most, this is by far the most defining feature of Spinnaker, and that is the built-in Canary Analysis. So here's Canary Analysis inside of Spinnaker. Again, this is our pipeline. So we duplicate our deployment, create a baseline version, we deploy our Canary, we run analysis, and depending on whether that analysis works, if we get a positive reading from our Canary, Spinnaker is going to go through the process of deploying it out as an official image. And delete our baseline and Canary as well, which is cool. Here's what a Canary analysis looks like inside of Spinnaker. In this particular case, we're actually looking at our web deployment, and it succeeded. So this one went out, which is cool. And again, just a reminder of kind of what this looks like. There's one thing I have to mention here. We talked about the tools that we use here at GIPHY, but there are a couple more that you're going to need for Canary Analysis. These are the metrics providers that you can use for Canary Analysis inside of Spinnaker. So New Relic, Datadog, Atlas, Graphite, Prometheus, and SignalFX are all available to use for Canary Analysis. Here at GIPHY, we use New Relic and Datadog. But today, I'm going to demo you Datadog. Just a very simple Canary that is CPU based. So yeah, but I wanted to show you what a New Relic analysis looks like. And this is a live Canary analysis for our web application, our front end, if you go to giphy.com. In this particular case, we generated a baseline, we generated a Canary, and this ran over a 30-minute period and generated a bunch of metrics for us. And then Spinnaker essentially decides for you based on Netflix's algorithm whether or not your Canary looks like it's working appropriately compared to the baseline that was already previously deployed, right? So in this particular case, we actually look at the aptX, the database call duration, the error rate, and the transaction time from New Relic to figure out over a period of time whether or not that Canary looks good. So now we're going to demo that. How's everybody doing? Okay. So here's the deal. We deployed out our code to our environment. Everything looks good. I think we're now ready to merge this into master. And when we merge to master, we're going to run our Canary. So let's go to GitHub. Uh-oh, I'm blocked. All right, so I'm going to go to GitHub. I'm going to go to my branches. There's my awesome branch that I made with my Pikachu GIF. I'm going to make a new pull request, call it awesome new GIF. And I'm going to merge that pull request into production. So what's going to happen now? Well, same kind of thing we saw with the branch, right? Jenkins is going to start up. There it goes. It's running master. It's going to build us a new master container. And when this is done, we'll use Spinnaker to deploy it out. So let's look at this Canary really quick while we're waiting for that to build. This is our pipeline, as you've kind of previously seen it. We go into our configuration. There's our expected artifact that we're expecting Jenkins to send us in its properties. And here's the automated trigger, right? So we're watching the master job in Jenkins to see if there's been any completions of jobs. And we're going to try and grab the property file if it exists from Jenkins to trigger this pipeline. So it's building, building, building. And almost done. Sweet. Cool, so we finished. So let's look at that JSON that got generated. There it is. So this properties file is now available to Spinnaker to grab inside of Jenkins. It will do so by calling out to it in a second. One thing to note here, little caveat to a Jenkins trigger, slower than a webhook. Why? Well, because it's polling based. So it can take a few seconds for it to come out. But there it goes. Cool. So let's watch this thing run. If we go to our pods inside of this namespace, we can see there's our Canary baseline generator job that's running, right? It's created our baseline object for us automatically. So that's now available to us. So if we go back to our master deployment, although you can't tell, behind the scenes, this is actually hitting the baseline and the original version of the app. And that will make more sense when you see the Canary in just a second. But let's go to the execution. So we go back to our terminal. A couple things are happening. So first of all, there's no need for that baseline job to exist anymore, right? So Spinnaker, as part of the pipeline, has deleted that baseline job for us. So goodbye job. And as soon as the secrets are generated, which you can see this little binary we have called Vultr has run. It's grabbed secrets and made them available to our underlying application. The Canary is going to come up and start spinning up, which is happening right now. So the important thing to kind of note here is we've got 3 running deployments. We've got a SpinPipe baseline deployment, and a SpinPipe Canary deployment, right? Those are our 3 currently deployed pods. And now, if we go to that same page, we have 3 pods. So every 3rd request should go to the Canary, right? 1, 2, 3, 1, 2, 3, right? There's our Canary available to test against. So let's, for fun, hammer the crap out of this thing. All right, I'm sending it 600,000 requests. Let's see what happens. Okay, this takes just an FYI, we're doing this very quickly as a Canary analysis goes. Most Canary analysis, to really get the right data, you're going to want to run your analysis for about 30 minutes to get enough metrics to really know whether or not your Canary is working properly. This is just a Netflix recommended amount because the more data, obviously, the better their algorithm is at figuring out whether or not your Canary is working properly. But like I said, we're hammering this thing pretty hard, so we got to wait 4 minutes. And I'm going to take questions while we're waiting for it. Anybody? Yes. I think that'll be made more clear in the last part of the presentation. Yeah, there's a lot of reasons, to be super honest. I'm going to keep one of them secret for just a minute. But Armory has done 2 big things for us. Number one, they built out a Terraform and a Vault module for Spinnaker. In our particular case, we use that Vault module to. I should be clear. The Vault module doesn't help you create secrets in like Kubernetes or something like that. It's used for at the startup of Spinnaker to grab secret values for Spinnaker itself to run. So for example, like your Datadog API keys, your AWS keys and things like that, you can store them in Vault and then have those values made available to Spinnaker when they start. Why that's kind of important, otherwise those are just stored as plain text inside of the Spinnaker config, and there's no great way of handling that other than like encrypting your config file and storing it somewhere. But that's a great feature inside of Armory. And the Terraform step is not open source, but although we don't currently use it, we have a lot of plans for it, such as like booting up entire clusters with that Terraform step. So pretty cool. Yeah, we got 2 more minutes. So happy to take any more questions or hear about gifts that you guys love that we have. My favorite's been recently the Keanu Reeves one at the start of this. So I think it's from a Netflix show, actually. Yeah. Yes. Yeah, so one thing to keep in mind. Yeah, so there's two actually big points to keep in mind there. Number one, Spinnaker doesn't actually use, anybody who might know Helm or knows Helm enough, you know that there's a service called Tiller that actually helps render a lot of your manifests inside of Kubernetes. Spinnaker does not use that. Spinnaker actually simply templates out the Helm charts with the same Helm engine as Helm, but it's the one maintaining all of the infrastructure because there's no need for Tiller essentially with Spinnaker, right? So it just completely forgoes Tiller and everything's maintained in Spinnaker. So yes, Spinnaker literally just uses the underlying Helm templating engine to help deploy out those manifests to Kubernetes. Yeah. Exactly. Kubernetes essentially handles the brunt of the work. Yeah. Spinnaker is the one that helps to handle rollbacks. You can actually roll back entire deployments. I can show you really quick. This is the object that we're gonna actually change in a moment, right? But you can roll back directly through Spinnaker to whatever revision of that same app you want, and the revisions are listed here, so you'll know, what container to roll back to and things like that. Exactly. Okay. Hooray! Canary Analysis passed. Oh yeah. I will tell you about that in a second. Yeah. Can we hold that for just 1 second? Sorry. Yeah. Cool. So Canary Analysis passed. We're now in the process of actually deploying out that official image, right? So if we go back to our terminal, we should see now that there's just one pod running, and that's our official pod. So if we go back to our SpinPipe app on the browser, now we are just getting that deployment, right? So what happened there? If we go into our Canary Analysis step, you can actually come in here and see the data that Spinnaker picked up from Datadog as far as what it has done, right? So this is the red line is the Canary, and the blue line is the baseline. And then you can kind of see the information that Spinnaker used to try and pick up exactly what's happened. In this particular case, there was actually a pretty big deviation, but Spinnaker probably didn't have enough information to really 100% be able to say if this app was a pass or not. But if you actually look at the metrics, they're actually kind of in line. So again, like I said, the algorithm really needs about 30 minutes of data to really give you a solid feedback. But it kind of just depends. And the cool thing is you can actually weight your metrics. So CPU is probably not a great metric to go off in a lot of times, like Nginx in this particular case. What am I really getting from that? But things like aptX, things like overall response time, those are metrics you'd want to use. And then if you go to your Canary configs in this particular case, you can actually weight them. You can group up your metrics and weight them. So, for example, your response time might be more important than something like the CPU usage, right? So you want to be able to say, well, just because the CPU usage spiked doesn't mean that this is a bad canary, because the overall response time is totally fine. So let's go ahead and move things out. Sorry, you had a question.
What kind of infrastructure do you use to run your operations? Do you have on-prem or is it strictly cloud? And if it's cloud, what type of cloud providers you use and why? And how do you also control the costs?
Well, cost is a whole thing. We can totally talk about that afterwards. But we are totally an AWS shop, actually. We use Fastly as our CDN. We use AWS as our cloud provider. I think do use Google Cloud for one or two things, but most of our infrastructure is AWS. And we're Kubernetes based, so yeah. Cool. Thank you guys for sticking around. Let's wrap this thing up. Oh, I gotta stop sharing. Nah. Okay, so last thing. Promise we're almost done. Pitfalls. These are the things I really think you should know about as you move forward with Spinnaker if you're interested. The first thing, this is 100% an enterprise product. If you are a startup, if you are a small team, I would never recommend this to you. And I'm going to explain why in just a second, but you really do need dedicated resources to help you with this. In our particular case, we're a small team. Like I said, we're 3 people. We partnered with Armory partially because for 3 people, this is a lot to maintain and it's a lot to build out. Which brings me to my second point. It's going to take a fair amount of development time to really get this to where you want it. Out of the box, Spinnaker can 100% be manually triggered via pipelines. You can trigger things off of like a Docker hub push or something like that. But to really get it to the point that we've invested, it's been about a solid 9 months of hard work and really just testing and iterating and getting things to work the way we need them to. So like I said, Brian and Anthony have been a huge part of that. Certainly not just me, but yeah, it's a fair amount of investment time-wise. The other big thing I would say, Kubernetes support is still pretty nascent in Spinnaker. It has come a long way in the past 12 months. Google's invested a lot of time and energy into making Kubernetes a first-class citizen inside of Spinnaker, but that was not what it was originally built for. It was originally built by Netflix to deploy out their Amazon machine images. So a lot of the naming conventions and things like that inside of Spinnaker still are like part of that old process. So just kind of keep that in mind. As an example of a way that Kubernetes support is still kind of nascent, here's how you have to handle true and false values that come from properties inside of Helm. You would think, oh, I can just pass Helm via Spinnaker a true or false Boolean, but nope, and you can't send it a string. It just comes in on a weird JSON format, and that's how you make it work. So whatever. Oh, it's fixed? See, these guys are awesome. Finally, maintaining pipelines can be extremely difficult. Remember those pipelines we saw? That's them printed out in JSON. Fun, right? That's about 23 pages of printed out JSON. Now, there are some things out in the ether that help to make this a little bit better. There's actually a new project being worked on by the Spinnaker community called Sonnet. If you've ever used or heard of JSON, it's essentially a fork of that. But the one I kind of want to mention here that is also open source is built by our dear friends at Armory, and it's the one we use here at GIPHY, and that is called Pipelines as Code, aka Dingy. And this allows you to actually take that and turn it into this. Hooray. Dingy is a Go templating platform that Armory has built. Again, totally open source. You can use it if you want to. But definitely work with them if you love it. And the cool thing about Dingy is you can actually build your modules and call upon module and module and module. What do I mean by that? Well, at GIPHY, we call them Lego pieces. But this is what our Dingy modules essentially look like. Your Dingy modules are stored in a GitHub repository, and you can go multiple layers down with your Dingy modules. So at GIPHY, we call the lowest level piece a module a block. Then we have something called a Lego, and then we have something called a box set. And so a box set would be multiple Lego pieces, and a Lego would, let's say, call multiple blocks. To kind of show you what that looks like, here's what the Helm manifest deployment stage Lego looks like. It's a small little file. You can see it's essentially just a Go templating language. That is called by the box set called Jenkins basic stages, where we provide it some additional information and variables. And then we have our Dingy file, which again is just multiple pipelines defined as modules, and you can see that box set is called there. And the cool thing is that the variables that come from the top come down to the bottom. So anything you define on the Dingy file level gets passed down to the box set module. Anything that's from the Dingy file from the box set module will get passed down to the Lego, and so on and so forth. So that's it. Really quick thing, 2 things. Number 1, thank you to Armory again for co-sponsoring. That is their website, armory.io, at Cloud Armory, if you want to follow them on Twitter. I don't know if you saw, but I also created a bunch of links to different things inside of the presentation. You can take a snapshot of that if you want to. And I promise we're going to come back to this slide in a second. But I don't know if any of you looked at jobs.giphy.com while I was doing this presentation because I was so boring. But we're hiring a senior site reliability engineer. If you're interested in joining our team, and we are awesome, I would like to think, you can hit us up on jobs.giphy.com. My name is Bryant. Thank you guys for coming. We really appreciate you being here.
Let's have some fun. Let's give away some free stuff too. Bryant, give me a number between 2 and 49. 36. Luke. I know you. Come on up. You want a Sega Genesis? Bryant, thank you. That was awesome. Thanks again to everyone from Armory, everyone from GIPHY, and all of you guys for continuously supporting us. Come back. We do these every month. The meetup's called DevOps and Drinks. Come by. Say what's up. Thanks again for everything, guys.
One more thing before everybody goes. First of all, I'm happy I'll stay and take questions if anybody has them. But also, Lee from Armory is actually going to do a short little presentation. It is an enterprise Armory feature. If anybody's interested in Armory, definitely recommend you stick around. So thanks, y'all.
Yeah, so one of the things that we were talking about is getting late. Bryant did such an awesome job that what we're going to do is we'll work with Alex. So we won't have your email address, but we'll work with Alex that we'll send out another Zoom link, and what we'll do is we'll do something asynchronous. What we're going to do is there's a feature that we're coming out with called a policy engine. So for those of you that maybe work in regulated industries, maybe in public sector, maybe financial services, healthcare, a lot of the things that we saw, we have customers who come to us and say, I can't just give my developers the ability just to push to prod. I need a way to have some sort of policies around it to be able to make sure that certain criteria are being met before things are actually deployed. So what we want to be able to do is we'll send out a link. If you guys are interested in that, you're more than welcome to join. We'll do it asynchronously. We'll record it. So those of you can then get an email afterwards if you're interested in seeing it later on down the road. But we'd love to have you. We're going to dig into some of the ways to be able to secure pipelines as well as stages through that policy engine. So thank you all for coming tonight. So it already has role-based access, but one of the things that we have is when you're just securing something with read-write, there may be something where I want to make sure that the person who's deploying to prod is not the person who actually just did the pull request. I want to make sure for SOX compliance are two different people. Some real complicated. Yep.